I'm Sana Ohira, and I'm going to talk about the physics of gymnastics. I did gymnastics for 6 years, but I had to quit last year because of my back. But I still love watching gymnastics on TV and was really happy when we won the Olympics last year. Gymnastics was first introduced in ancient Greece about 2,500 years ago. The ancient Greeks practiced gymnastics to prepare for war. In the late 18th and 19th centuries, two physical education instructors, Johann Friedrich Gutzmuth and Friedrich Ludwig John, who are known as the fathers of modern gymnastics, developed the parallel bars. And by the 1830s, gymnastics reached the United States and was included in the Olympics in 1896. However, women were not allowed to participate in the sport until later. In 1928, they finally joined the Olympics. At first, women used to compete in the same events as men, but today, men and women compete in different events. Men compete in 6 events: floor, pommel horse, rings, vault, parallel bars, and high bar. Women compete in 4 events: vault, uneven bars, balance beam, and floor. And today, I will be talking about the physics of 2 events of women's gymnastics. The first event I want to talk about is vault, my personal favorite. Vault is an event where a gymnast runs to a table at the end of a runway, then springs off, doing flips and twists in the air before landing. It is also one of the 2 events where both men and women compete. When vaulting, Newton's first and second law is involved. Newton's first law states that object in motion will stay in motion unless acted upon by an outside force. This means that a gymnast running toward the vault will stay in motion until an outside force acts on them, and after the vault, the gymnast will stay in air until an outside force, in this case gravity, acts on them. Also, Newton's second law, F equals ma, is used. This means that mass and acceleration are directly proportional. So, to produce the maximum force, the gymnast needs to run fast to gain acceleration. Next, I'm going to talk about the uneven bars. This is a video of a gymnast doing part of her bar routine. As you have seen in the video, gymnasts transfer from one bar to another. They revolve around the bar several times and then let go, breaking the centripetal force. Then, they will fly in the direction of the linear velocity until they reach the next bar. When they reach the next bar, they revolve to recreate the centripetal force. Also, friction plays an important role in uneven bars. Friction is defined as the resistance to motion of one object moving relative to another. By applying chalk to their hands, it increases friction between the bars in the gymnast's hand and helps the gymnast glide smoothly around the bar. It also helps prevent their hands from sticking to the bar. Thanks for watching. I hope you enjoyed it.